Okay guys, okay, this is video 2 on the questions that we're answering on in CS110I. So question B, which reads, if 01001101 is the ASCII representation in the letter M, write down the representation of the letters I that are given, which is JQTV, that the carry 4 marks. I think 2 for each question. Okay. Oh, is it 2 for each question? 1 for each question. Okay, 1 for each question. Okay, so in that case, let's first identify something out. Something that we have here is that we have the code I, the number, which is 01001101I. So this number is in at ASCII. So this is an abbreviation I. This abbreviation stands for American Standard Code of Information Interchange. American Standard Code of Information Interchange. American Standard Code of Information Interchange. So, okay. So this is a representation. The same way we can say that A is equal to 1. So in this case, they've told us that 01001101I. This number means M. So find the other numbers like JQTVI. So to change this number into the numbers that are given I, so one thing that we should know first of all is that the number written here, which is 01001101I, this number, looking at it properly, it's only made up of zeros and ones, and there's no better definition of it that's coming in mind, or better meaning of it, than me identifying this number as a binary number. This is a binary number or a binary digit. So this is a binary digit that is representing M. So if this number represents M, what do they mean by find the other values, or find the JQT, because those are letters? I mean, how can you find them? So in this case, it's the same way when you are given a number like AI. If A is 1, meaning B is 2I. The same way we find by A is followed by BI. So if A was 10, meaning B was supposed to be 11. That's just automatic. Yeah, because A follows after B, or B follows after A, sorry. Yeah. So now, how are we going to find the JQT and VI? So in that case, the only way we can find the JQT and V is by first converting this into a decimal number, unless you have a way of counting that you can reach to J faster than that I. But I think the only better way here is by doing as I, by interchanging, I mean by converting first this number into a decimal number, because a decimal number is better to read than these other numbers. So let's continue. So I'll change this number, which is 01001101I, into a decimal number first of all. So how do I change number to a decimal number? I had given a formula of changing numbers to decimal numbers, and I had named it what? Summation of face values plus summation of face values times their position values. Face values times the position values. I'd say that an I. So this is 0. If I want, I can even cancel it, because 0 is 0 is 0. Whether you try to make anything out of it, but it's 0. Okay, but let me just keep it, because it has I think in this case it will have a meaning. Let me just keep it for now. So in this digit that we have here, let me try to identify the values I. So in 01001101I, this is a 0, this is a face value, since we're base 2I, so base 2, this is 2 to the base 0, this will be 2 to the base 1, this is to base 2 to the power 0, 2 to the power 1, power 2, power 3, power 4, power 5, power 6, power 7, reaching to the power 7. Okay, this is interesting. Okay, so to the power 7, don't forget, this is a test. You can use a calculator. This is computers, not like math where they tell you that don't use a calculator. So in this case, as I said earlier, summation of the faces and their values I. So this is a face, so I'll write the face times the position value. This is 2 to the power 7. I'll write the face again, so plus the other face, which is 1 times the position value, which is 2 to the power 6. The other one is 0 times 2 to the power 4 or 5, sorry. Another one is another 0 times 2 to the power 4. Another one is 1 times 2 to the power 3. Another one is another 1 times 2 to the power 2. The other one is another 0 times 2 to the power 1. And the last one being 1 times 2 to the power 0. Space sila no sila. Okay, in this case, this one, no matter how big it is, since it's times 7i, that would be 0. That's why at first I was like, it doesn't matter if we eliminate it I. So that would be just 0 plus this number here is 2 to the power 6. 2 to the power 6, that should be 32. Is it 32? Let me just check with my calculator. 2 to the power 6, 2 to the power 6. 2 to the power 6, 2 to the power 6 is 64. Since 2 to the power 6 is 64, so times 1 is just 64. So I write 64 here. 2 to the power, so 0 times, that is 0 times something I. So 0 times something in that case, and if I know that it's 2 to the power 5i, I think this is the one which gives us 32. But in this case, since it's times 0, it will be 0. Even this is times 0, it will be just 0. And then this is 2 to the power 3 times 1. So we're just going to get to the power 3. 2 to the power 3 in this case is a number which is that is 8. That is 8. This is 1 times 2 to the power 4. 2 to the power 2i, which is 4. And then this is 2 to the power 1 times 0. So if it's times 0, the answer is 0. And then 2 to the power 0, 1 times 2 to the power 0 here. 1 times 2 to the power 0. I know it's not clear because I was writing fast, or I was writing big things and I forgot about space. But 1 times 2 to the power 0, 2 to the power 0 is 1. So it's plus 1. So adding these numbers together, we have 64 plus 8 plus 4 plus 1i. So this is a 12, 13. Adding it here, we're going to have a number known as 77. So in the case that we are now fully aware that the number m stood for 77i in decimal number, meaning in base 10. In base 10, the number was 77. So m is here. So this is m. So I've said that this m is 77. So what other numbers are we looking for? We're looking for the number j. We're looking for the number q. I'm just going to circle them. Q, we're looking for the number t, and we're looking for the number vi. We're looking for the number v. So let me just collect that data. So this is 77. If this is 77, meaning this is 76i, and this is 75, meaning this is 74. So j is 74, and this is 77, 78, 79, 80, 81. So this is 81. And then this is 82, 83, 84. This is 84. And then this is 85, 86, meaning this is 86. So in this case, let me just verify. This is 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86. Okay, everything goes according to plan. So meaning in this case, we have j, which are converting. J is 74. We have q, which we are converting. Q is 81. We have t, which is 84, and v, which is 86. So what's our last goal here? Our last goal is to change these numbers to change them back to base 2i, since we're dealing with base 2, meaning why we're changing them to base 2 is because the number mi was given in base 2. So meaning they require us to leave our answers always in base 2. So how are we going to leave our answer in base 2 in that case? Okay, so I'm going to change this in base 2. So the method I'm supposed to use to change that in base 2 is then to use the ladder method So I'll use the ladder method. So 2 as a base, going against 74. Don't forget, as I said earlier, please don't mind the calculations. You can use the calculator. This is computer studies. Okay, so 2 into 7, that is 2 goes into 7 about 3 times. I remember 1, that one goes to make 14, and then 14 was 7, meaning there's no remainder there. 2 into 3 goes 1 time, 2 into 3 goes 1 time, remainder 1. 2 into 17, that should be 8, remainder 1. 2 into 18 goes about 9 times, remainder 0. 2 into 9 should go about 4 times, remainder 1. 2 into 4 goes about 2 times, remainder nothing. 2 into 2 goes about 1 times, remainder nothing. And 2 into 1 goes about 0 times, remainder 1. So that's what we have for QI. Okay, I'll come back later. Let me first finish the rest I. So we have 81. Numbers are increasing. I hope the space will be enough. Okay, so 81 for Q. Okay. I'll just try to minimize the space so that it fits. Okay, so 81 going against 2, or 2 going, okay. So 2 into 8 goes about 4 times, meaning 2 into 1, it doesn't go I, meaning that is, it doesn't go 0, remainder 1. We have that. So 2 into 40, or 2 into 4, in this case I, that goes about, is it 2 times I, so 20, remainder 1. Oh, 0, sorry, remainder 0. 2 into 20, I'm sure that is 10 I, remainder 0. 2 into 10, that is 5, remainder 0. Too much zeros. 2 into 5, that goes about 2 times I, 2 times, remainder 1. 2 into 2 goes about 1 time, remainder 0. And then 2 into 0, or 2 into 1, that goes about 0 times, remainder 1. So we have this number. Okay, we have now 84 for T. This is 2R. Okay. 2 into 8, don't forget, it goes 4 times. 2 into 4, it goes about 2 times. There is no remainder there. 2 into 4 goes about 2 times. 2 into 2, 1 time, no remainder there. 2 into 1, 2 into 2, that's 1. 2 into it cannot go I, so meaning 0, remainder 1. 2 into 10, that is 5. 5, remainder 0. 5, 2 to 2, oh, 5, 2 into 5, 2 can go into 5 many times, about 2 times, remainder 1. 2 into 2, it's 1 times, remainder 0. And then 2 into 1, that's 0, remainder 1 I. So we have that. Please don't feel bored of calculation. Calculation is my favorite thing. That's why I'm doing things fast, actually, because I love calculations. Calculations in my blood. You can also be one by always practicing these things. They become easy. Practicing numbers, not just computer, mathematics, everything. If you practice every time, these things will be easy. Okay, so 2, and then R. Okay, 86. How many times does 8 going to 6? Okay, at 18 going to 6. I blacked out there. So 2 into 8, that goes 4 times, remainder no remainder, so into that is 3, remainder 0. And 2 into 4 goes about 2 times, remainder nothing. And then 2 into 3, that should be 1, remainder 1 I. Okay, 2 into 3, 2 into 21, it's the same as here. So I can, if I want, I can get this whole part. It's the same thing. Just waste okay, 2 into 22, that's 1 I, meaning 2 into 1 is can't, so 0, remainder 1, as I did earlier. 2 into 10, it is 5, remainder 0. Okay, 2 into 5, oh, you're not even seeing. Oh, I never saw that the calculation went somewhere else. Yeah, 2 into 5 here, 2 into 5 I. 2 into 5 goes about 2 times, remainder 1. 2 into 2 goes about 1 times, remainder 0. 2 into 1, 0, remainder 1 I. So even this one, we're going to get it from top to, or from bottom to top I, from bottom to top, like that. So we're done with all the numbers. What's remaining is just identify which is for which. So in this case, your number one question, which was asking for J. So J in this case, we found that J is this number here. It is J has become the number 1001010. So we're going to write it. J is equal to 1001010 of that number, and then number two we had Q. So Q, which was 81, Q was 81, and in this case Q means 101001001. So 1010001. So I'm going to write it here, 101, 3 zeros and a 1 again. And then we have number 3 as, is it V or T? It was T, T, which was 84. 84 in this case now meant 84 meant it is here. It meant we have 101010100. 1010100. So we have 1010100. Okay, and the last one, which was that, the last one in here in this case was 1010110. So 101010110. So that was V, which was 86. 86 meant 1010110. It meant that. So that is the end of question B. That's how it was supposed to be answered, and you have for the 4 marks.